Okay, I don't see much join, but anyway, let's get started. Probably join us at some time. Is my screen visible to everyone?
Yes, sir.
Okay, great, thank you. Okay. So before we start, I think Friday is a holiday. So for keeping that in mind, then we just have 4 more days left. So today, tomorrow, and then Monday, and probably since Friday is a holiday, we might have to take 1 more day on Tuesday. But let me check and get back to you on that. But anyway, it's going to be 4 days what we will be doing. And yeah, so we have completely Kubernetes untouched. So what we'll do is like again, yeah, I'll try to cover all the important facts of it, but it will be good if you guys can let me know as soon as we complete, right? Uh, we'll be able to save some time there. If everyone has complete, then we can just quickly go on to the next topic. But it doesn't mean that you have to skip the practice, but once you practice, let me know so that we'll see how we can cover everything in the next 4 days. Okay, now just to recap, what we did in the last session was how do we generate our own pipeline using the Jenkins pipeline as a code, wherein what we saw is every time you do a build, we are not just going to hand over the jar or var like earlier. Instead, what we are going to hand over is a Docker image which contains our application. So now, when we talk about a traditional deployment, so you take a machine, put all the necessary packages in it, and then copy your artifact and then run that. So instead of that, now moving forward, when I say deployment, it's all about take an image and create a container out of it, and you should be having everything from that. But the problem that what we will be facing as we move forward is when you say create a container, so it will be on a particular machine in which Docker daemon is running. And for a real-time scenario, you will not be always using a single machine to do all the container creations and managing. So in fact, we need multiple machines in which containers has to be created. So that's where the third part of the Docker, which is the container orchestration, which is nothing but how are we going to manage containers on more than one machine. If it's a single machine, we will directly go to the Docker client and you run the command and we will be interacting to the Docker daemon. But now think of 10 machines and all the 10 machines Docker is running separately. How will you create containers, start containers, stop containers, which is going to be a problem. So which is what we need to understand. But before we go there, now let's just take some simple examples to understand what is the meaning of orchestration. Okay. Now, for a minute, think a cab as a container. Okay. Now, let's say at office or at home, you're planned to go for a movie or a lunch. Okay. So you might have booked a cab for certain people in your team, and let's say that the cab came, and the time that you are going to start, you will see that some other colleagues want to join you. Now, what will happen? Now, this is where, especially like when you're going for lunch, you can't just leave them. So you need to book another cab, and all of you guys have to go together, or it's the same thing in the family, right? So in this requirement, what you need is at the moment that you want, immediately you need another cab. So realistic way of thinking, you won't get a cab immediately because you need to book a cab. For that, you have to go and find another mobile and try to search which is the nearest cab and wait for that cab to come. Correct? So only then you will be able to get a new cab. So basically, the requirement here is you're trying to duplicate your effort in traveling, which is not going to happen immediately. Okay, so there is some time that you're going to waste to make sure that you get everything duplicated, or in the sense you will get a similar cab so that all of you can go together. Now, in the same way, when you talk about a cab, let's take another example. This time, assume you're going to take a flight, okay? Or let's say that you have a plane to catch at a particular time, and you book the cab and you're on the way to airport, and suddenly your car breaks down. Okay, what is that you're going to do? Now, once again, from wherever you have stopped, you have to think of getting a new cab. So once again, you have to book a cab and wait for that to come, and then you're going to move from there, right? Because if you wait to fix this car, it's going to be too late for you. So you need to make sure that you are in a situation where you can get a replacement cab whenever you want. But again, for that, it's going to be a time-consuming process. And now comes the interesting thing, especially our Indian weddings. So let's say on a wedding day, you wanted to go to the chowdhury or the marriage hall, and you would have booked some car or some kind of vehicle to take few people. But as soon as you see a vehicle, there will be a bunch of more guys who want to get in, and everyone wants to come with the bride or the groom. Then what will happen? So all of a sudden, from a four-seater or a six-seater vehicle, you want a 20-seater or a 30-seater vehicle so that you can accommodate everyone. So your requirement is kind of increased. The capacity is increased. Everything is the same, but capacity is going to be increased. So how are you going to solve that? So this is where, once again, it's not so easy where you have to call someone and get a bigger vehicle, which will be replacing your current vehicle, right? So again, there's going to be a lot of time that you're going to spend in it. So in all these things, we are seeing three use cases: replication and recovery from a failure and scaling. So these are the three things that we are looking at. Now the same thing, if you apply to your container, what will happen? This is when you take a machine, for example, let's say the machine has 12 GB of RAM, okay? And you install Docker in it and Docker daemon is running. And if you want to create a container for an application, let's say that application needs 4 GB, okay? So what will happen? When you run a container, it is going to consume 4 GB from the host machine, and the leftover on the host machine is close to 8 GB. But out of 8 GB, there will be some capacity which the operating system also takes. So hardly you might be left with around 6 GB. Okay. Now, what if I want to create 2 more containers? Then it will not be possible, because in this machine, the maximum that you can create is only 2 containers with 4 GB of each capacity. So how will you solve the third one? So then this is where, like what I was talking about a car, you need a new machine in which you are going to create the container. Okay. So now in real time, if you see, we will not always have one machine, whether I'm using it for my QA deployment or for my production. You're going to have multiple machines, and in that, depending on the capacity available, you are going to create containers. Because now, let's say I have 4 machines, just for example, because I can't always depend on one machine. So I will create a bunch of machines. And now if I ask you, okay, I am giving you 4 machines and help me in creating 2 more containers, then what will you do? So once again, you need to first know how many containers you already have and how many containers totally you need. So if I say additionally 2 more containers on top of what you have, then on which machine you will create. So this is where you have to go to each and every machine and find out what is the capacity available, and in that how many containers I can create. So based on that, you're going to create new containers. But think of it in a way where what is the time that you're going to consume in going through each and every machine, finding out what is the capacity available and what is that you need, and then think of how many containers to create. The same way, if I have to create more containers, then that is the problem where you need to know what and all are the machines currently you are having, and in this, how many containers are there, and how many containers that you can create for your need. So that's where it's going to be time consuming process, and you need to go to each container, you need to go to each machine and create the container. Now what happens when all these containers are running, wherein let's say totally you wanted 6 containers to be always running across 4 machines. Now, suddenly, for some reason, one machine went down, and what you wanted is 6 containers. So what will happen in this? So you have to continuously monitor and make sure whether your 6 containers are running. So in this case, if a machine goes down, now in that machine, how many containers were there? 2 that you have to recreate. So where will you recreate? So once again, you have to go through all the machines and find out which machine has capacity and calculate and then create the container, which is going to be once again a big headache. Okay, because more number of machines are there that you use, then this process is going to be a time consuming process. Now, not just this. Now let's say this time all the 6 containers are running. There is no problem in the machine, but for some reason, one of the container specifically is not working fine. So this is where, how do you know whether container alone is not working fine or the application inside the container is not working fine? And that is where we need another monitoring process in which first you need to make sure if you want 6 containers, always the 6 containers should be running. And if it is not running, you have to replace it on any of the available machines. And at the same time, if I say containers are running, it is not sufficient, but we also have to make sure that it is running fine. So how do you check that? Then you have to go to each and every container and execute some commands and find out whether your application is also running fine or not. Because if something goes wrong with that container, once again, you need to recreate a new container. So once again, when I say recreating a container, in which machine you are going to do? So the same process keeps moving. So the more number of machines you have, it's going to be very difficult for you to manage multiple containers. Now, this is another problem. Now, keeping it aside, let's talk about the next problem. So in production especially, what will happen is, to do a load balancing, you are going to have multiple copies of your instance, right? Now, let's say that you go to facebook.com or linkedin.com. Which one are you accessing? You don't know, correct? Because internally, that connection will be load balanced to some other machine. Now, in that way, when we use Docker, we know when I have same application running across all the machines, there will be the same port available on each machine. But when I want a user to access it, how will I redirect a user particularly to this machine or this container or this container or this container? And in that, what will happen when you have more than one container in the same machine of the same type? Okay, then exposing the port will also be a problem. So how are you going to do a load balancing, which is another problem? Because in production, the same copy of the container will be running and all of them has to be load balanced so that the access should be not going to the same container again and again. Okay. Now, these are the problems what we are going to face, for which we know that using a single machine in production or in a real-time environment will not be possible. So that's where what we are going to do is we are going to use a bunch of machines put together and we are going to create a cluster out of it. And now in that cluster, what we need is some kind of orchestration, which is nothing but the ability to manage containers on multiple machines put together. And that is what we call it as a container orchestration system. So now when you have a bunch of machines in which Docker is running, and in that, if you want to manage the containers, then we are not going to use the Docker directly by going to each machine. Instead, on top of Docker on all these machines, we need another utility which is called as the orchestration tool or system. And what is the necessity of it? So first thing now, if you see, when you create multiple containers, you should be able to find out whether the container is running fine or inside the container, the application is running fine. Now, rather than you doing it, you will tell this to orchestration system, and that orchestration tool or system will go to each and every container that is available in your cluster, and it will try to check. If it is not healthy, it will try to recreate the container. Same way, when you are creating a container, it is not that you will be creating just one container. So you will be creating multiple containers as a copy, and you want to make sure that the same copy is always running. Okay, so that you can do load balancing. So for that, now what we can do is we can go to the orchestration tool and we can tell, hey, I need 2 copies of my container, and it is the responsibility of the orchestration system to create 2 containers and make sure that 2 containers are always running. And we don't have to tell where to create. So the orchestration system or the tool should go through all the machines in the cluster and decide where it is going to create. Okay. Now, same way, it's not that you will always have a fixed number of containers. Now, in production, on load increasing, you might have to create more copies of your containers or decrease them. So that is what we call it as scaling. So once again, what we can simply do is use the orchestration system and tell, hey, I don't want 2 containers, I want 10 containers. Then what is that additional 8 containers it has to create? Where it has to create should be taken care by the orchestration system. Our job should be just to tell, create containers or scale them. That's all. And where to create, how to create should be taken care by the orchestration system. So that is how it is going to be easy for us. And then there's another important topic which is called as rolling update. So what happens in production? It is not that you will be running new containers. So there will be already a container which will be running, and that will have a particular version of your application. And later on, when you are doing a new release, you will develop, test, and build a new application, and corresponding to it, a new image will be there. So now, how will you replace the existing containers with the containers from the new image which has the latest version of application or product? And that's where you need to know that it should be not causing any issue in production, because if I have to stop all the running containers and then create new containers, then it is going to be a outage in the production where customers cannot access. So that's how safely, how are you going to replace current containers with the new containers is what we call it as rolling update. Okay. And finally, load balancing. So regardless of whether I have 2 containers or 10 containers and where the containers are running, that is which machine it is running, if we use a load balancer, we should be able to redirect the traffic to all the containers in a distributed way. And that is where the orchestration system will help us to set up this. So these are the reason why we go with an orchestration tool, because just by using one machine, we cannot achieve our deployment. So for that, we are going to use multiple machines put together as a cluster. Okay. So this is the first thing. Now, the question is, what is the orchestration tool? So earlier, we had a tool called Swarm or a Docker Swarm, which was a built-in option. But later on, moving towards the cloud native solution. Now, Kubernetes is the popular tool that is in the industry to manage containers, or Kubernetes is a container orchestration tool. So what will happen now is, when we are creating a cluster, we will take a bunch of machines, and in that machine, Docker daemon will be running. Now, on top of that, we will install Kubernetes and create a cluster. And now, whatever that you want, if you want to create 1 containers or 2 containers or 10 containers, you tell that to Kubernetes, and Kubernetes will find out what are the machines available in the cluster, and it will create the container, and it will make sure that the container is always running. And in case if the container goes down or a machine goes down, in which container is running, it will replace that with a new container. For that, once again, in which machine it has to create, that will be taken care by Kubernetes. Okay. So that's when Kubernetes gives you the tools using which you can tell when to create a container, where to create a container, and how to create a container. Okay. So all you have to do is you have to now give a desired state. So when I say desired state, what is that you need? So I want to create 1 containers or 10 containers. Now for that, which image to take, what port to map, what environment variable to pass, what should be my startup command, what should be my volume mapping. So everything you give, and Kubernetes will take care, and it will make sure that the same number of containers is running on all the machines. Okay. Clear? So that's where Kubernetes is an orchestration tool which will be running on top of Docker. So going forward, we will not communicate to the Docker. So we will communicate to Kubernetes, and Kubernetes will communicate to the Docker on each machine, wherein Kubernetes will be managing the orchestration of multiple machines put together as a cluster. Clear so far? Any questions or doubts so far?
Yeah. No, madam.
Cool. Okay, so now I use this word called as desired state. So when we try to use Kubernetes, what will happen? We will take a bunch of machines in which Docker is installed. On top of that, we are going to install Kubernetes and create a cluster. Okay. And what is that we need as a desired state we are going to give it to Kubernetes. And Kubernetes will make sure that it will create that, and it will always monitor and make sure that the same state is available. Okay. Now, in this, what we need to know is the architecture of Kubernetes. Okay. Now, when we talk about architecture, so just like Jenkins, in Kubernetes, you have two types of machines. One is called as the master machine or control plane. Okay. So especially if you are setting up Kubernetes on cloud, like AWS or Azure, then the master machine will be generally called as control plane. Okay. If not, generally what we call it as a master. And on the other side, we have individual nodes in which the actual containers will be running. So these are called as Kubernetes nodes or worker machines. So what is the need for this two types? So remember, anytime the containers that you need will be created on worker node. Okay. Whereas the machine in which the administration happens is what we call it as the master machine or control plane. So just like Jenkins, we use the Jenkins dashboard, which is on the master, and we automate the job on which slave node it has to run, correct? The same way, now any interaction that we want to do to the orchestration tool should be happening through the master only. Okay, so we will not go to any of the worker nodes and tell to create container. So you just go to the master, and there will be some tools using which you will be telling what is your desired state, and Kubernetes will find out which machine has capacity, and based on that, it will create container. For that, it will download the image from a registry on to that particular machine, and it will create container. And post that, it will monitor all the containers. For any reason, if a container goes down, it will try to replace it on a different machine. So that's how you tell the desired state to the master, and master will communicate with all the worker nodes. Okay. And how do we communicate to the master? So this is where now there are some UIs using which you can communicate to the master, or you can use some command line utility to communicate. But regardless of this, internally, the master or the Kubernetes control plane has certain APIs. So using that APIs, we are going to communicate to the master. Okay, and in that, you can write some file in which you are going to give your desired state in a declarative way. Okay, we'll see about what is that declarative way. So what will happen now in Kubernetes, you are going to write a file in which you are going to tell your desired state like a YAML file, and then you will call some APIs and tell what is that you need. So Kubernetes will take the information what you want, and it will store it in the master, and based on the details what you have given, it will try to set up on all the workers as it is needed, and it will be monitoring. So anytime if what you have defined in your desired state in the file is not matching with what is there in the group of machines, then Kubernetes will try to bring that up. That is where, for example, you told 6 containers, and right now you have only 5 containers. So it will match it and find out, okay, this guy told me 6 containers, but I see only 5 containers, so let me create a new container. Or you told now to scale from 6 to 10 container, and then when it looks, it will say, okay, this guy has told me 10, and but what I see now is 6. So let me just go ahead and increase the 4 containers. For that, which machine to do, where to do, Kubernetes will take care. Okay. So Now, if you get little deeper into the components of master, okay, and slave or worker, we need to know certain things. Now, basically, the master has four important components. Okay. Now, when I say four components, those are called as etcd, and then controller, scheduler, and API server. Okay. Now, let's try to see all these things one by one. Now, what happens whenever a user is trying to communicate to the master or the control plane? We will be using some commands or UI, but that will communicate through the API server. Okay, so API server is a component of your master which helps us to communicate with the user. Okay, now over here, what will happen is all the input that the user is going to give will be received by the API server. And then what the API server will do is API server will store that information, what you have given as a desired state. For example, I want two containers and port to be mapped in 80, and then a particular volume that should be there, all those kind of things. So you will put it, and that will get stored into a location called as etcd or key store. So the information of your desired state will be stored into this from the API server. Okay. So API server will receive from the user and it will store it into the key store. And then what happens? So that is where the next component called controller will start its work. So the duty of the controller is to check what is the content that you have stored in the key store as a desired state and what is exactly available in your cluster as the actual state. Okay, so it will try to check the difference. So that is where, depending on what it finds, for example, if it is the first time where you have told I need some container, and if there is no such containers, then the controller will take necessary action to create that container. Or you have told some container and that many containers are not running, then it is the duty of the controller to give what is the workload. So workload means what to do now. So that's where controller will take the desired data from the etcd and it will also check from the actual cluster, and if it doesn't match, it will tell what to do. And this is where now controller is like a manager. Okay, it will not go to the machine and do something. Instead, the workload it will be giving it to scheduler, wherein controller will say, for example, hey, this guy wanted to create a container. There is no such container. So I want you to go to machine 1 and create this container. So that way, controller tells the scheduler on what it has to do to achieve the workload. Okay. So controller reads from the key store, checks what is the desired state, and anytime if there is a change needed, it will go ahead and update the scheduler to do the work. And finally, scheduler is the one which will be communicating to the worker node, and it will be telling to create the container, delete the container, or monitor a container, what it has to do, it will tell. Okay, so that's where, once again, whatever the input that we are going to give as a user will be received by API server, and that will store into key store, and the controller will read it, and based on the desired state not matching, it will tell the scheduler on what is the workload it has to perform. And scheduler is the one which will be connecting to the respective machine, and it will get the things done. Okay. Now, this is on the master. But if you look at what do you have on the worker, or what we call it as Kubernetes node, So there are three components. One is kubelet, and then proxy server, and then Docker engine. Okay. So now what happens in the Kubernetes nodes or the worker nodes, there is a component called kubelet, which is the one like an agent which will be communicating to the scheduler or the master. So whatever the workload which the master is sending to a particular machine, that will be received by kubelet. Okay. So kubelet will receive the traffic or the workload, whatever is coming from the master, and based on that, it will tell to Docker engine on how to create a container or to delete a container, those information. And at the same time, whatever the master wants, the information about the cluster, it will also pass the information about what is happening to a container, how many containers are running, what is the status of the machine. All this information will be sending back to the master with the help of kubelet. Okay. So kubelet is the component which receives the communication from master. At the same time, kubelet is the component which will be sending the information back to master depending on what is the status. All right. Now, in addition, there is one more component called proxy. Now, for now, don't worry too much, but just remember this, that in order to communicate between all the worker nodes and for us to access the application and doing the load balancing, there is a network setup needed within the cluster. And that is what this kube proxy is going to do. Okay. So anytime if you think of communication between containers within the cluster or communication between outside world and container, that will happen through proxy server. So proxy server gives the networking and communication path. Okay. So these are the components what we are going to have in master and worker. So now when we start running, we will never ever interact to worker. So all we are going to do is to the master, we will define a YAML file and we will be communicating to the API server. Just to recap, API server will read the information of the desired state and it will store it in the etcd, and controller reads it, and based on a necessity action, it will be creating workload and it will tell to the scheduler. And scheduler will be passing the information to the kubelet, and kubelet will receive it and tell the Docker daemon what it has to do. And the same way, kubelet is going to collect the information of the machine and send it back to the master or control plane. Okay. So this is how the basic architecture of Kubernetes looks like. But for us, we are just going to communicate only to the master. And like Docker, now since Docker can be installed on a bare metal or a cloud or a VM, same way, Kubernetes, since it runs on top of Docker, you can run Kubernetes also on bare metal or on top of VM or on cloud. Okay, all those things are supported. Getting it? Any questions so far?
For the AP server store the information in etcd. What type of format it is, a DB or some other format?
It's a key store file.
Oh, okay. Okay.
Yeah, it's a data store where it will be storing everything into key and value formation. It's not an exact database, but it's more of a bunch of files where it stores everything in key value format.
Okay.
Okay, so if you have understood this, now what we need to know is objects. Now, before I jump, okay, so what we have to do now is we need to first know how is that the communication is going to happen to Kubernetes master or control plane. Now for that, I told you that there is going to be a file which is called as a YAML file, in which we are going to give everything in a declarative way. Okay. Now, when we talk about YAML file, now YAML is again a file in which you are going to give the content in a key and a value combination. So what I'll do, let me first talk about how does a YAML file look like, and how are you going to give the input, and based on that, we'll just see later on what are the other things that we can do. So when you take a YAML file, right, the name of the file should always end with .yml or .yml. The name can be anything, it doesn't matter. And when you are trying to write a YAML file, you are going to basically put everything in a key and a value. Now, when I say a key, it's a word where again it could be any word, but it would be something like a key name, and then followed by you're going to give a colon, and followed by that you're going to give some value wherein there should be a space. Okay. Now you will be having multiple keys like this. Now, just to give some example, so let's say we'll put it up like name, location, Bangalore, and let's say subject. All these things are keywords. So you're going to have a key and a value. For that, you're going to say key name, colon, a space, and a value. So you can have multiple keys like that. However, sometimes a parent key can also have a child key. So for example, like this. So let's say I have key 2, and under key 2, I have child keys. So whenever you are defining a child key, then you need to give a space. So how many space? It doesn't matter, but you can give as many space as you want, but all the child keys under this parent key should follow the same space alignment. So for example, here, if I say key 2.1 and some value, and suppose if I have another child key, then it should exactly start in the same. So this is what we call it as indentation, where you need to make sure the same amount of space is available everywhere. Now, you cannot give like this. It will give you an error because neither this is a parent key because all the parent keys are aligned here. Same way, neither this is a child key because this is different alignment, this is different alignment. Okay. But remember, if you put one more space and give this, then the 2.2 becomes a child key for 2.1. So that's where it's more important on how you give the details. Okay. Now let's say, for example, here. Now, if I keep subject as the parent key, then here I will say here topic is participation. Then we can say tool, and in that, suppose if you also want to have a child key, and then we will say server. So this way now, subject is the parent key and topic and tool are the child keys for subject and server is a child key for tool. So this is how what will happen. You are going to give parent and child key. So that way, all the parent will be grouped and all the child will be grouped, for which the space or indentation is very, very important. Okay. So remember this. And another thing that we need to know is when we are trying to give a YAML file, whatever the tool it is going to read it, in our case, Kubernetes API server will read, even though it reads the entire content of the file, you are going to put certain keys together as a group and you will be telling some action to perform based on a group of keys. So that is where, how do you group some keys? So then, anytime if you want to group some keys, it will always begin with a hyphen like this. So now, if you look at now, key name and key two are parent key, which is part of one group. And same way, if I want to have another group, then I can have like this. Okay. So all these things are different keys, but when Kubernetes is running, it will try to read it in groups or what we call it as section. Okay. So for example, here you can put this as one section or one group. Same way, I can put this as another group, but now there should be a alignment. This is how when Kubernetes runs, it is going to read all of them in groups or sections. Wherein subject is the parent key and these are child keys. Now, you can also have a group within a group or a section within a section. Okay. Now, for example, let's say I have here, let's call it as user. Okay. Now here I can have some other details. Okay. So let's say now, this can further have one more group. Okay. Now here say box. Okay. I'm trying to put some keywords. That's all. Now here I can also say. So now if you see, I can have section inside section. Okay. So put dots. Or this can be like 2, 2, 1. Okay. So now you can see this is one parent group or section, and inside that this is a child section and this is a child section, and in that these two are parent keys and these two are child keys for. So that's what more important is the space. So whatever you see here, these are called as space and with indentation. Wherein how many space you want to give, it's completely up to us. But we need to make sure all of the related keys are in the same way. For example, here if I want to change, I can give this also one more space. This is also fine, but alignment should be there. So this is where in YAML we need to know. So as we move through, so when we see how to write the YAML file for Kubernetes, what you have to remember is you have to define wherever it is needed in section, which you are going to make a group, and you're going to have every line in key and the value combination, wherein all the parent keys and child keys, you have to group it and align it with indentation for space. So this is what are some of the basics of the YAML file. Any question so far on this? Okay, great. All right. Now, as we get started, now we need a machine. So, does everyone have a machine which has at least 2 CPUs and 4 GB of RAM, preferably a Ubuntu machine? Everybody has a machine? Okay. So what we will do, we will try to set up Kubernetes. See, when we are trying to set up Kubernetes, there are 2 ways you can do. So you can in fact create an actual cluster, but for that you need at least 2 machines. One is master and one is worker. Okay, so that once you set up a cluster between those 2 machines, you can go to the master and tell whatever is needed, and Kubernetes will communicate to the worker. If not, what we can actually do is we can take something called as Minikube, and using Minikube, you can set up a small Kubernetes cluster which is all in one machine. So the same machine will act as master, the same machine will act as worker. So for your practice, you can use that. But when you go to a real-time production, you will have separate master and multiple workers. But for us to practice initially, what we will do, we will take one machine, and in that we will set up Minikube, and using Minikube, we will be able to tell that the same machine is going to act as master as well as slave. Okay, so that is what we are going to do. Now, instead of that, when you go to production, if it is AWS, then you can use a service called EKS. If you go to Azure, then there is a service called AKS. If not, if you are having your own VMs and you want to set up Kubernetes, then there are some tools like QADM using which you can set up everything. Okay, now, depending on the time available, probably I'll show you how do you set up, because I don't think you guys are using cloud. So at the end, if time permits, I'll take a bunch of machine and I'll show you how to set up master and how do we set up slave or worker separately. But as of now, we will try to take one machine in which we will install Minikube, which will be acting as all in one machine. Okay. And for this, I'm going to take Ubuntu because it's quite easy to set up. If you take any other machine, then it is going to be little complex. So that's the reason I'm going to take Ubuntu for that. Okay. So yeah, so for Kubernetes to run, that is the master to run, whether you are running it through Minikube or separately, minimum of 2 CPUs and 4 GB RAM is needed. Okay, so make sure you have a machine. And what I'll do, I'll go ahead and create a new machine. I'm going to use AWS for that. So AWS Ubuntu. This is where I need 2 CPUs. So I'll take a machine with 2 CPU. And storage by default 8 GB is sufficient. So let me just name it. So what are the things we have to do? Now, since we are using Minikube, this one machine will be acting as complete both master and worker. But in this, what we are going to do, we need to basically set up Docker first. And on top of the Docker, it is going to run all these things. Okay. So, okay. This is where what we will do is just type this commands. Everything is not working. So, this is the steps. So first, let's go ahead and install Docker. Okay, so Docker is installed. Once Docker is installed, just cross check whether you are able to run it. Okay, so Docker is running. Next, for us, we need to install a utility called as kubectl. So kubectl is the command line utility to interact to the API server. And since this is a Minikube, both it has master and worker components into it, automatically set up. But for that, the only thing we need is we need the kubectl to be installed. And using this kubectl, we will be communicating to the API server of the master. So for that, let's install kubectl. kubectl is available. Done. Now we are going to install Minikube. Now this is where Minikube is one small application which will set up all the components needed for master and worker on the same machine together. So it will be like an easy setup. Okay. So Minikube is also available. But what we need to do is we need to basically install one more package which is needed for Minikube. So once it is done, then we can start Minikube. So when we start Minikube, it is going to basically run all the components of your Kubernetes master and the worker on the same machine where we are doing. Okay. So just go ahead and give the start command. This will take some time. You just have to wait. Okay. So here, what we need to know is now, especially if you are using a virtual machine, so you need to know what kind of the virtual driver that you are using. Suppose if I believe you are going to use more of VMware or any other KVMs, then what you can do when you are starting the Minikube, in the driver, I have given it as none here. So what you guys can do over this place, now try giving KVM or KVM2. So see if VM driver none is failing, then you can just make sure as KVM2, which is what I believe you might be having. But if not, if you are aware of what is your virtual machine driver that you are using, then typically that you can keep. Okay, so once you give this and start your Minikube, now if you come back to cross check, I can just say Minikube status, and it should show that control plane is running and your API server, kubelet, all of them are running in the same machine. Okay, and also you can simply say kubectl get nodes. So this should show you there is only one machine which is acting as a control plane, as well as the same machine will act as worker. Okay, so try to set this up and see whether you are able to bring up Minikube and a small Kubernetes cluster. Let me copy paste this. And please try that and let me know if you are able to bring up Minikube. Okay, we'll just wait for others. Okay, everyone else is fine. Okay, so if you guys have done it, take a break for 10 minutes. For those who are not done, just try to complete it. Let me know if it's a problem. Take a break and we'll see back in 10 minutes. Is everyone done? Okay, so everyone is here. So let's get started. So what we need to understand here is in Kubernetes, if we are going to tell our desired state, which is nothing but how many containers you want, and in that container, what should be the image you should use, what port to map, volume to map, environment variables, startup commands, all those things you're going to give. But how is that you're going to define? So that is where in Kubernetes, there are objects that we have to create, and for every object, there will be some property. So in fact, you will not be directly telling that you need a container. Instead, you are going to create an object, and for the object, what are the properties that you want? That is what you're going to tell. And based on the object, Kubernetes knows what is the state that it has to maintain. So this is where now, if you are going to create a container, how the container should be behaving, based on that, there is an object we have, okay? Because we cannot just directly create a container. So that's when in Kubernetes, it's all about learning what are the different objects we have, and based on your need, how the container should be behaving or what is the property of the container you need. So based on that, there will be some corresponding objects that we are going to have. Okay, so objects are nothing but one more layer on top of your container. Okay, so that is how it is not the container that we are going to manage using Kubernetes directly. Instead, there will be one more layer on top of it, which is what we call it as object. So when we take this YAML file, whatever the content we are going to write will be defining an object, and the object will tell how to handle the containers. So that's where what are the different types of objects available in Kubernetes, and for us to get a particular functionality, how to define that object is what we need to know. Okay, so remember, everything is going to be object. So from now onwards, whatever we are seeing is completely an object. So out of this, the first object that we have in Kubernetes is called as pods. Okay. Now, what is a pod and why do we need? So to understand this example a little more better, let's go back to the basics of Docker. So if you remember when I was going through Docker, I told you like a container is like your tiffin box. Okay. And depending on how much you eat, you will be having different boxes or dabbas that you will carry, right? Now, for your lunch, let's say you're carrying rice in one box or one container, and you have dal in another container. Now, individually, these are called as containers. But for you to have a lunch, you will have a requirement of taking more than one container, right? And it is not just container. Along with the container, what are the other things that you guys carry for lunch? Yeah, pretty much for the past 1.5 years or so, you wouldn't have done. But what were you doing before that? When you say you're taking lunch to office or work, so you need some containers, whether it is one box or two boxes, that's up to you. But in addition to it, you might carry a juice box, you might carry a kerchief, you might carry a spoon, right? So you put everything together, and that is what you call it as your lunch. Now, how do you carry all of them? So you're going to usually take a bag, which is where you have this all Tupperware bag or whatever, and you put everything that is needed for your lunch. So that is where you will carry your lunch bag, inside which you will be having multiple containers or container boxes based on your need. And along with that, you will have your kerchief, your spoon, your juice box, everything together, right? So that's where when you say lunch, all you are going to refer is whatever is needed for you to carry, not just the container boxes. So that's the same way in Kubernetes, what we need is a container. That is the underlying thing. But when we say for us to deploy an application and run it as a container, along with the container, just like how I was telling for your lunch, you need spoon, you need a juice box, or a curd box, and you need some tissue papers. The same way for your deployments, along with the container, you might also need some more properties. Now everything put together is what we call it as a pod. So you can consider pod as your lunch bag. Okay, and your actual boxes will be inside that bag, right? The same way in Kubernetes, we will not create containers directly, but instead we actually create one more layer on top of container, which is what we call it as pod. Okay. So now whatever Kubernetes is going to create or handle, it is what we call it as a pod. And pod inside it will contain or it will have the containers. Okay. Now, by default, when I say I need one container, it is not I need one container. It is I need one pod, and inside this pod, I will be having a container. Okay. So just remember this. And every time when you say Kubernetes, you need a pod, internally it means you need a container. So one pod refers to one container inside it by default. And suppose if I say I want 2 copies of my container running, then in Kubernetes, it means you are going to have 2 copies of your pod. Okay. So there will be one pod with 1 copy of container and another pod inside it, another copy of your container. So that's where Kubernetes is going to manage everything in terms of pod. Okay. So going forward, forget about the word container. Anytime if you refer container, it is nothing but it is pod. So Kubernetes will first create a pod and then inside that it will create the container. So pod is just like a layer, like a lunch bag. Okay, so remember this. Now, When you create a pod will be created on one machine. Okay, and the container inside that pod will be running on the same machine only. So it is not like your pod will be in one machine, your container will be in another machine, because pod is just a layer on top of container. On some scenarios, within a pod, two different containers can run. Okay, try to know the difference what I'm saying here. If you are having copy of the same container, then it is called as copy of the pod. Suppose within the pod, if you are going to have more than one container of different type, that is also possible. But in that case, now if you look into a pod, you will be having more than one container. Now that will be a very rare scenario, because by default, when I say pod, you will always have one container. But it's not mandatory. Within a pod, you can have two different containers running. But if you want the same copy of the container, then it is like another pod only. Okay. But when I say a pod and all its container inside it will be residing in the same machine. Okay. So for any reason, if the pod is crashed or not working, then obviously the containers inside it will also not be working. It will get deleted. If the pod is getting created on a new machine, then inside it, the containers will get created fresh. So that is how going forward, Kubernetes will handle everything called as pod. And by default, every pod will have one container. Okay. So now, whatever that you are going to create and manage, everything will be pod only. And inside the pod, container will be there. So now when you are defining an object, which is pod, you will also define what is the spec for that object, which is nothing but how many containers you need and what is the image needed for this container, port mapping, volume mapping, everything you are going to give inside it. All right. So remember, as long as the pod is running on a machine, the container inside it will also run. Now, how does a pod gets created? So when you define an object and you tell Kubernetes that you need a pod, Kubernetes will go and search in all the machines in the cluster, and whichever machine matches the requirement what you have told. So on that machine, first pod will be assigned, because pod is just a layer. So once the pod is assigned in it, then inside that pod, Kubernetes will create the container. And as long as the pod is running, container will also run. But sometimes pod will be there, but container might get crashed or it might be exited. So in that case, now on the same machine, the pod will just try to recreate the container inside it. So remember, container get be stopped, restarted within the same pod. But if the pod itself is crashed, the container will also get deleted. So a new pod will come, and based on that, a new container will be coming. Okay. And every pod has a unique ID, just like how we have a unique ID for a container. A pod will also have a unique ID. Now, when we say pod, it's the simple object. Okay. So it doesn't have any other property. The only purpose of pod as of now is to just create a container on a machine and run it. That's all. Okay. So by default, pod will have only the ability to create a container on the machine and then just keep running, and it won't do anything else. So that is where, as we move forward, we need to understand what other objects that we need, which will run on top of pod, so that you will be getting different functionalities. Okay. So now to understand this, let us first create a pod and see how does the definition of pod work. Okay. So as we move forward in Kubernetes, so the Kubernetes YAML will look something like this. Now, don't worry, we will get into deeper one by one, but let's understand some of the basic overview. So as we know, YAML is more of a key and a value pair. So now, if you open the Kubernetes YAML file, which we generally call it as a manifest file, where you are defining the desired state of an object, for which you are going to first tell what is the kind of object. Now, there are different types of objects, which is what we are going to learn. The first and the basic one that we are now seeing is pod. So you have to tell the type, which is the kind. And then for every object, there will be a particular API version which we will be communicating. So that we need to tell through this keyword called API version. And then you're going to have something called as metadata, where what is the name of this object, and we'll learn some concept called label. So what is that? We will see. And then for every object, you're going to have a spec, which is what will tell the desired state. And inside this, if you are creating a container, then for that container, what name, what image, what should be the startup command, which directory it should run, what code should be mapped, what environment variable to map, and if you want a specific resource to be allocated. Because as of now, what we will learn in Docker is whatever the resource is available on the machine, the container will get everything. But using Kubernetes, when we put a pod on top of the container, we can tell how much of capacity that it should be using. So that is what resources is about. Okay. And then how do we check whether container is running fine or not? For which we have something called as health checks, which is also something we will do. So like this, for a container, whatever the properties we want, we will put. But as of now, pod means it's just like a small box inside which your container will be created. And what are the properties for the container? But as an object, it doesn't have any other additional functionality. So we will see what are the additional functionalities needed. Okay. So now to take our first example, okay. So let me take this. This is what I already here. This is the first example. So if you see here, what I'm trying to do is I'm trying to define an object of the type pod, and anything that you see hash and on the right hand side will be considered as comment. And the API version for the pod is v1, and the name for the pod we will give it as test pod. And inside that we need one container. So for that container, we will just say the name of the container. So what should be the image that we are going to use, and what should be the default startup command. So I'm just giving a small one-liner shell script, which will be just printing the name every 5 seconds. Okay. And what is this option called restart policy? Again, you can see it is for all the containers that you can create. So if I say restart policy is never, for any reason, inside the pod, if the container gets stopped, pod will not restart it. If you do not give this option, then the restart policy will always be set as always. So at any time, if the container gets stopped, the pod will automatically recreate the container in the same machine where the pod is assigned. Okay. So that way, remember, we are not going to create containers directly. So we are going to use an object called pod. Now, to run this, let me go back to my Kubernetes machine. So I'll create a file. So I'll just call it as pod1.yaml. So you can keep any name. Now comes the next question. How are you going to run this? So this is where, if you remember, I was telling that there is a utility called kubectl, which we are going to use. And that's where Using kubectl, we will be telling how the Kubernetes master should be reading it and what it should be doing. So you define the desired state in the YAML file or the manifest file, and then use the kubectl to communicate to the API server. So when we use kubectl command, the options what you are going to tell us, the command what you want to do. Like, do you want to create a new object, or do you want to modify existing object, or delete the object, or do you want to list the object or describe details about the object? That is what we call it as command. And then against what type of object you want this command to be executed. So that is where type represents what is the object, whether it is a pod or a machine or different kinds of other objects. And then what is the exact name of that object which you want to run this command. So that is where it's a combination of these three things. Okay. Now, some of the basic commands that you can run is, first, when you have the cluster, to see what are the machines available, you can say kubectl get. So get represents get some information from the cluster. Okay, for this, what is the object which you want to get? So this is where the worker machines and the master are also considered as one of the object. So if you say kubectl get nodes, it will show you all the list of machines available. Okay, so this way, instead of node, if you put pod, then it will show you whether there is any pod running currently. So you can see it says nothing is running. Same way, now if you want to describe, now if I say kubectl describe, and what you want to describe. Suppose if I want to describe the object called node, and then the name of the node, which is this one. Okay? It will give you all the details about that machine, what is happening. So this is how we will be using kubectl commands. Kubectl node and then now if you want to get the list of pods, you will say kubectl gets pods. And as of now, we don't have any pod. So this is where if you want Kubernetes to take the content of this and store into the etcd, then you are going to say kubectl apply. And whenever you say apply, you can tell which object you want to apply. If not, we are trying to put everything in a declarative way. So simply say -f and the file name. What will happen? Kubernetes will read the details of your object, and it knows what you are looking at, and it will try to store it into the etcd, and then the controller will pick up and create it. Okay. So now watch the same. If I go back, we have the file available here. So just say nothing. So now if I say apply enough, so it says it created a pod. So to cross check, if you say kubectl get pods, so now you can see there is a pod created, and that pod is actually creating a container. And the status of that, now if you see, what you wanted is one container by default or one pod, and in that one container is already running. Okay. And if you want to see where exactly it is running, then you can say get pods -o and it will show you now. Once you did the apply, Kubernetes created or assigned this pod on this machine, and on this machine the container got created. Wherein, remember, as of now, both the machines are same. Okay? Because we have just one machine in Minikube wherein the container is created. Suppose if you have multiple machines in the group, then the kubectl apply would have created a machine on some other, created the pod on some other machine where the resource was available. Right now there is only one because Minikube is like all-in-one machine. So this is where now your container is created on this particular machine. Okay, and anytime if you want to delete object, then you can say kubectl delete and the object name. Instead of that, if you just tell the same way of file, so whatever the object you have defined inside it, it will try to simply delete the object. Come back. It will take some time to delete. But once it is deleted, the container inside that will also be not available. So now if you see, there is no point. This is where container creation, updates, or deletion will happen everything through your state file or the desired spec which you have given in the YAML file. Okay. Now let me put this into this main file. So quickly. So let's go to this project. Here, let me just copy paste. No what comments. So just do a git pull in your workspace. You will get this latest file and just copy paste this and create a file called pod1.yaml and then just go ahead and run and see how it is behaving. So try running it and see. Okay, others, have you tried it? If you have tried, so the first example, what we saw was how do we just basically define a pod, and in the pod, how is that you are going to give some basic configuration for your container spec. Now, here, let's get a little deeper and try to see what are the other options available. Now, unlike Docker, let's say, for example, if I just go and apply this again, so there will be a pod created. This pod will create a container on the machine. And now, how do I know whether the container is running or not? So this is where you can go ahead and use the describe command for the pod also. So for a describe, you will say kubectl describe is the command, and then what is the object, which is the pod, and then which is the name of your pod, which is this pod. And this will show you, if you look at this, now whenever you said apply, Kubernetes assigned the pod to this machine, which is the only machine available. And then in that, inside the pod, your image is getting downloaded. And then from that, a container is created, and then a container is started. Okay, so which is the basic of your Docker. But who's doing it now? The pod is doing it. The Kubernetes is doing all these things through the pod. Okay, and in Docker, if you are running a container and you want to check whether what is the logs running in it, so you used to say Docker logs by going into that machine. But in Kubernetes, you don't have to do that. Instead, you can just go to the master from where you are executing kubectl, and if you just tell that to the pod, and by default, pod will redirect the commands to the container. So that way, now all you have to do is say kubectl describe pod. Now, for you to look at the logs, you can just say kubectl logs and -f and then the pod name. Because whenever you have one container in the pod, if you refer to the pod, it is going to redirect it to the container. So now on my cluster, I can go to the master and run this. So I don't have to go to the machine where the container is running. Okay, so that is the advantage. So you can just say kubectl log f and your pod name, and this will redirect to the container. So in the container, you can see we are running this command. So whatever is the console output of the container inside your pod, this will directly show. So that's where when you have one container, In the pod, if you refer to the pod, it is equivalent to referring to a container. Okay. Now, same way, if you have a requirement to go inside the container. So in Docker, we used Docker exe and we safely executed a command or we went inside the container. The same way, in Kubernetes, any interaction will happen only through the pod, not to container directly. So that way, you will use kubelet exe as a command, and here you will tell what is the pod name and followed by double hyphen and what is the command that you want to run. For example, I'll just say apt update. So what will this do? So the apt update command will be executed on the container which is inside the pod. Okay. Now for this, it doesn't need us to go inside a container. So if you just run it, you can see it just runs the update. And cross check, if you say kubectl get pods, you should see one container inside the pod is running fine. So there is no problem. All right. Same way, what if you want to go inside the container? And that's where, similar to Docker, you can use kubectl exe test pod, and here you are going to say -id and followed by touch. So this way you will create a new shell and that will be executed inside the container, because every time in the pod when you have only one container, referring to this pod refers to the container. So now what's this? Let's say kubectl exe you are inside the test pod, and in that you are inside the container. Okay. If you look at this, now this is the command that you are running, which is the parent process, and bin bash is what you just now ran. And whenever you come out safely, only this bin bash will be stopped, so your parent shell will be still running, so nothing will happen to your container which is running inside the pod. So this is where you will not be interacting to container. Instead, you have to reach to the pod, which is the layer, and that will be redirecting it to the container. Okay. So once again, anytime if I go back and delete, what will happen? It will just remove the pod as well as the containers along with it. Okay, so you will not have anything. Quickly try this now, so that we will see how different behaviors will be faced. So try to create the same pod and see how the logs work and how does the exe work.
Adam, you are on mute. I think. We can't able to hear you.
Am I audible now? Hello? Am I audible?
என்ன சொல்றது?
Now, is that to me? Am I audible?
Yes, Adam.
Okay. So, I think what I was giving you in this example is, instead of one container, if there is a need where you have to run two containers, then you're going to have different sections, so that you can see this section or a group defines the spec for one container, and this defines the spec for the second container, and both the container are different. So in the first container it will print my name, and in the second container it will be printing hello students, and both these containers will be running on the same machine. Okay. Now, how do you look at the logs of this? This is where, when you are trying to say kubectl logs at the pod name, so it will clearly tell you that there are two containers. So which container that you want? So that is where, when you have more than one container, you are going to basically give the container name, wherein you can just give the container name like this. So right now it will show only the first container, and if you want to see the second container, then you can just go ahead and say C01 and it will show you. Okay. Same way, if you want to run a command against a particular container, then when you say kubectl exe, you can also say -c and which container you want. So for example, I'll just show PSE. So this is the first container where my name is getting printed, and the same, if you go ahead and just say C01, you should see the next one. So this way, in pod, you have two containers as your desired state, and both of them are running. But again, it is one pod, two containers. And if I go ahead and delete pod, then it should also delete all the containers together. Okay. So just try running this and get pods. Try to say before that apply. Check the logs. You can say C and the container name. So C00 or C01, whichever that you want. Same way, execute command on a particular container. You can say -c and the container name. This is what it is. So just try looking into this on how you can create a pod with two containers inside it. So let me add it here. Yeah, I've checked in the file. Just try to pull and you will get the latest content. So try running this. Okay, so let's wait for others. Okay, cool. So if everyone has done, it's fine. So is there anyone who's still trying? Any problems or issues? Sure. So if everyone has tried, then so you don't have to stop Minikube. You can just go and stop your VM itself. So tomorrow, once you create a once you start the VM, all you have to do is just start the Minikube once again using the same command what we did. Minikube start. Okay. So if not, you don't have to restart anything. So I'll show you tomorrow what you have to do. But just start the VM and then start the Minikube, and you should be getting back your kubectl get command, and everything should be working. All right. Sure. So let me stop it today. So if there's no questions, then I'll talk to you guys tomorrow. All right. Sure. Thanks, then. Have a good day. Thank you. Okay, thanks, guys. Have a good day.